Hey everyone, welcome back to day 50 of Coding Every Day. Today we're going to do merge triplets to form target triplet. So I've never seen this problem before. Alright, so let's look. You're given a 2D array of integers triplets where triplets of I represents the ith triplet. Okay, you are given, so it's going to be an array of triplets. You're also given an array of integers, which is the triplet we want to obtain. To obtain target, you must apply the following operations on triplets 0 or more times. Choose two different triplets and update the right one to become the max of both of them. Okay, so you can merge a triplet by, so if you have a triplet, okay, so I'm going to reiterate the problem in my understanding. So we're given a list of triplets, and we can apply 0 or more merges to obtain the target triplet. And what that means, so the merges is we can, when we merge two triplets, we can basically just pick the max of every element. So if we have like 2, 5, that didn't work. If we have 2, 5, and 6 as one triplet, and we have 1, 4, 4 as another triplet, and we merge these triplets, it will produce, so the right triplet will become will become 2, 5, 6 in this case. It doesn't say that I has to be less than j though, so I think we can just pick any two triplets. So we can pick any two triplets, and one of them, okay, so the idea is when we merge two triplets, we pick one of them to overwrite. So this would go to, so let's say I want to overwrite this one, so in this case this would be j and this would be I, so it would become 2, 5, 6, and then 1, 4, 4. So in both cases, yeah. So I think the way I'll probably code it is, okay, fine, like get the merged triplet, which you take the max of each of them, and then I would replace either one. Okay, so I think with target, we can kind of think of it, so we have a target. So if we look at this one, we need 7 in the first position, 2 in the second position, and 3 in the third position. So how do we get target as an element? So we need it as one element. So in this first example, we have 1, 2, 3, and then 7, 1, 1 as our triplets. And we want to get 7, 2, 3 as an element of our triplets by merging. So I'm looking at it and I say, okay, here's 7. So we know that 7 should be the first one, and then 2. So here's 2. So when I see 7 is here, I'm thinking, okay, we could make either one of these the max right now, because if we merge into this one, 7 will go here, which is fine. So either one of these could have 7 at the front. But if we were to do that, then just the 2 and 3 would be there. I'm going to look at another example that has more, because that example just requires only one merge. So let's say we have 2, 5, 6, 1, 4, 4, 5, 7, 5, and 5, 6, 5, 4, 6, and our target is, no, that's our target. Okay. So, okay, so here's the 6. So we can never change values. So we need to make sure, so I guess a good place to start is we need to make sure that there exists a 5 in the starting position of any of the triplets. That has to be true. We also need to check, is there a 4 in any of the second positions? Which in this case, there is. And then here, the 5 is here. And then the 6. We need to make sure there's a 6 in one of the end positions. So I'm not a paint expert. Okay. So, and then here there is a 6. Okay, so we can see here basically, we have 3 different ones that we need to merge. So we need to keep this 6, we need to keep this 5, and we need to keep this 4. So if we were to merge this one into here, we would lose this 4. So we can't do that. I also just want to state, so a brute force solution would be to do every merge. Actually, I'm not really sure how the brute force would work. Okay, so I'm thinking, okay, so let's say we want this one to become our answer triplet. Then if we merge from here to here, 5 would be correct, so we'd have 5, but then 7 would overwrite this 4, so we can't do that. What if we merged this one first? So if we merge this one first, then 2 would overwrite, and then 4 would get overwritten. So I'm noticing because 4 is what we need, and it's also the minimum of all of the second elements, that means it's not possible. It's not possible. So if I were to simplify this, if I have, let's say 1, 2, 3, let's just say I have 1, 1, 1, 1, 0, 1, and like 2, 1, 1. Okay. And then our target is 2, 0, 1. So this would be impossible as well. And the reason for that is we need 2 in this position, or we need 0 in this position. And neither of those are possible. And the reason is 0 can't, so we always have to merge like downward. So our target character 0, we have to merge into this one. We have to merge into this one because 0 cannot spread anywhere else. If that makes sense. Like we can't ever merge 0 to either of these because the only way for 0 to be in the second is for it to be merged into. So that being said, the only way for us to get a 2 would be to merge into here. And that would make it 2, 1, 1, which would overwrite the 0. Yeah, so this does have to do with minimums and maximums for sure, and I think that's why it's labeled as a greedy problem. Because, for instance, we have a 5 in the first position. Okay, so I'm thinking we have a 5 in the first position. So that means we have 3 choices. Either we do not... And can we do... Yeah, we can do many merges as well. Okay, so the way I'm thinking about it is because 5 is the maximum element here, that means we'd either have to merge it into something else or another 5 would have to come and merge here. Like if we had 5, 0, 0. Well, then that wouldn't change it. What if we had 5, 9, 9? Then that would just be this one. So I'm thinking we'd have to merge the bigger one to the smaller one. So let's consider 4, right? So we know we have to combine those, but my question, I'm just thinking, like, is it possible that that would be like 4 merges down the line? So I'm getting a little paralyzed by that thought, but let's just keep going. So, okay, so let me undo these arrows. So I'm thinking, okay, so we need these two to go together because this is the only one that has a 4 in the second position, and this is the only one that has a 5 in the first position. So that being said, we must merge either this one there or this one there. That has to happen. We could do intermediary steps. So we could merge like here and then into here, but you can never get smaller. Your numbers can never get smaller. So no matter, okay, that's useful. So no matter what we merge this with, we know that these values must be greater than or equal to 5, greater than or equal to 7, or greater than or equal to 5. What was it? Yeah, 5. So we know after 0 to infinite number of merges, the values either are the bigger value in which they stay the same, or they merge with a larger value in which they get replaced. So these values always have to be in this range. So maybe we can think of these values as ranges. So here would be, it has to be 2 or greater, here it has to be 5 or greater, here it has to be 6 or greater, and then we have 1, 4, 4. Okay. So now when we look at it, it kind of becomes more obvious that, so we've simplified it into infinite number of merges. Now we have a range. So we have a number that's always going to be bigger than 5. Or let's forget about 5. So we know that this 5 needs to merge into one of these. Or, so that's one option. Or we have to merge this 4 into one of these. Okay, so here we can identify, all right, so this is useful. So here we can identify that 4 cannot merge anywhere. 4 cannot merge anywhere, right? So 5 can merge to 2 different places. It could replace this, or it could replace this. 4, no matter how many merges you do, will never be able to go here because 4 is less than 5. And it will never be able to go here because 4 is less than 7. So that gives us the information that, so it narrows our scope down to, this has to be our final triplet. This has to be our final triplet. And remember, our points of interest are this 6, this 4, and this 5. Okay, so now we know we have to merge into here. So that means we would have to do this merge, and that means it would get rid of the 4, which means it would be false. So that this is false, right? Okay. So let me apply similar logic of reasoning to another. So let's say 1, 2, 3, 7, 1, 1, and our target is 7, 2, 3. Okay, So if we define these, just think of these all as greater than, did I get the symbol wrong? I might have had the symbol wrong. No, it was right. So think of all these as greater than or equal to. So, and we need a 7 in the first position, a 2 in the second position, and a 3 in the third position, right? So we'll identify these. So we see that this 2 has mobility. It could go here. We see same thing with 3. It could go here. We see this 1 does not have mobility. We see this 7 does have mobility. Okay, do we know which one we have to merge on? I don't think it matters. So this one says update the second triplet. Couldn't you also update the first triplet though? So I could make this I could make this J and this I, and then I could say J will become max of AI, so it'd be 7, 2, and 3. So in this case, there is no specific place that you have to merge on. So in that case, I don't really know what I would do. I guess you could pick either one. Okay, so let me think of another example. I'm just going to make up random numbers here. So let's say we have 5, 4, 6. So 5, 4, 6, say 9, 1, 2, and say 3, 5, 5. And our target is, so off the bat, right, our target has to, so if we have A, B, C as our target, A has to be somewhere as a first position, B has to be somewhere in the second position, and C has to be somewhere in the third position. So I'll just pick numbers at random. So I'll say 9, 5, 6. Okay, so here, so we can just rule out anything that doesn't fit that criteria as false. This is like the real problem though, if it does. So 9 is here, 5 is here, and 6 is here. I'm also realizing too that there could be a 9 here, and then we'd have like 2 different 9s, which is kind of another problem, but maybe we'll develop an algorithm and then come back to that later. So, okay, so this 9 can go, it has mobility. That's just what I'm going to call it for now. This 6 can go here or here. This 5 can go here. I'm going to do colors. I'm going to color coordinate it. So let's say red, orange, and yellow. I'm going to do red here instead, yellow here, and orange. Okay, so 6 can go here or here, red can go here or here, orange can go here or here. So in this case, it seems like it would work. Because you can move the 9 here. Which then, so let's say we merge these two, and then we get 9, 1, 2, 9, 5, 5. So this is our new problem. And then we would want 6 to go there, which it can. Okay, so in this case, it would be possible, because then we would merge these two, and we'd get 5, 4, 6, 9, 1, 2, 9, 5, 6, and then we would get it. Okay. So this is interesting because, okay, we're saying 9 can go here, but what if this was, for instance, a 7? Then we would say this is no longer true. So here we have this still works, and this still works, but we can't go 5 to 7 anymore. And I think that's important because you need to know that there's a two-way connection. And what that means is, so if I go here and put a 9 here, it's not going to get rid of this. And we know that if 5 is bigger than this. The other number, I don't know if we care about the other number. Okay, let's think. Do we care about the other number? So here we know that we could not merge here because we don't have a two-way connection. If this was a 7 also, then this 6 would not work. So in this case, we see that nothing can go into here. So that may be significant. Because now the problem's impossible. So I think it's about figuring out what goes into each one, like what is greater than, and you have to kind of make this network, perhaps, or just use these relationships. So if this number is less than or equal to 5, we're good. And if this number is less than or equal to 6, we're good. Does this number have to be less than 9? Okay, and there's another tricky aspect to it too, because what if we had like this, right? 5, 4, 6, 9, I don't know, 1, 2, 3, 5, 6. So now it's even trickier because, and if our target was, let's say, 9, 5, 6 still. So if our target was 9, 5, 6, it's trickier because 9 is here, 5 is here, but 6 could be here or here. Okay, so I'm going to say that 5 can replace this, and it can also replace this. 6 can replace this and that, and then that's two-way, and 6 can replace this. And now, so when I see here, for instance, I think that this is important. So we see that the target numbers can replace both of these numbers, so they're bigger than it, and we have that target number, then I think that's when we know it's successful. So we have to figure out, for each triplet maybe, is this spot less than or equal to the target for each one? And if that's true, is it just true that it'll work? So I'm going to try coding this. So for this example, we would see, okay, what if we had 977, 546, and 355, and our target was 956. So this triplet would be true. This one would be false. So it would be true, true, true. This would be true, false, false. Then this would be true, true, true. So I'm checking, is this number greater than its target equivalent? So can we use this now to determine the problem? So if these are 1s and 2s, then it is true. So does every single one have to be less than? Well, there's also some we can ignore. Like, what if we had 10, 10, 10? So this would be false, false, false. But we can ignore those. So it's like we need the 1, and then if we also had like 10, 4, 10, this would be false, true, false. So we need at least one triplet that's true for all of them that contains our target, I think. So first of all, I think you ignore all triplets that don't contain a target. Okay, so ignore all triplets that, and I'm not sure if this is right, but I just want to try it. So we're going to ignore all triplets that don't have a target, because we don't need that ever. So either it's bigger, in which case it ruins things, or it's smaller, in which case we don't really care because it doesn't have a target anyway. So we're going to ignore all triplets that don't contain a target. Okay, and then we need to get at least 3 triplets that are true for all digits. So I'm thinking like we'd have something like, okay, we have a triplet. Okay, so we'll have 0, 1, and 2. Is it? Yeah, so it's always triplets. Okay. So we'll have, so for now, I mean, you could think of it, I guess we could do an array. So we'll have false, false, false. So we'll have an array of size 3, which corresponds to each target position. If we find a triplet that has all trues and a target value, we will make the index true for whatever index the target value is at. So when we encounter this one, we say, okay, it's all true, like they're all less than or equal to the target values. So we have a 4. So like, okay, here we have one that's a target. Our target index is 1, so we'll make true equal to 1. And then here we encounter this one. Okay, it's all true. Our target index here is equal to 1, so we'll make this true. And then here, it's all true. Our target index is, so this one was actually, I made a mistake. This is actually, should have been like that. And then here we encounter this one. and it would be true. And then we would return if all of these are true. Okay, so it's somewhere to get started, for sure. So we want to loop through, so we'll say for triplet in triplets. And then we'll have okay, so for triplet and triplet. For triplet and triplets. We also have target. So we need to check if the triplet is valid or not. So we'll say, so this is not valid. This is valid. So I'll make a function called check validity, which will take in a triplet and target. And then it will either return true or false. So it'll say for I in range 3. We'll say has target equals false. We'll say if triplet of I in target has target equals true. I like that. Okay, so this will and then we probably want to say target index equals -1. So if it's not -1, then we know it has it. And then also what we want to check is if triplet of I is greater than target of I, then return false. And if we get through the whole thing, we'll return true. So what I'm thinking here is, oh wait, but we also need to make sure, return if, I guess I'll say if target index equals -1. Okay. So I'm thinking that this will basically tell us if all of the, so if every digit is less than or equal to the target, corresponding target digit, it will return true. And also one of them has to be a target. Okay, so we'll say valid equals self.check validity of target. Sorry, of triplet, and we'll pass in target. Well, I guess I could just return target index. So it'll give me the index. Okay, if target index equals -1, then we can continue. So if it doesn't have a, if it doesn't have anything that's in target, so if triplet of I, so if 5 is in there, but it has to be at the corresponding position. So like if we have, for instance, 500, but our target is 050, this doesn't have anything that we care about, actually. So it has to be aligned. So if it's equal to, then we know this is the number that we want. Okay, so if it equals -1, then we can ignore it. All right, and then we could say result of target index equals true, and then I'm just going to print result. So let me see what this looks like. I forgot to give self. Okay, so this should be true, but my answer would return false. So let's look at this. So we have 1, 2, 3, and 7, 1, 1. And then we have 7, 2, 3. So it'll go through. So this is, let me just make sure my logic's not backwards. So triplet of I doesn't equal, triplet of I is not greater than 2 equals, so target index will be 1. And then 3, oh, what if we have multiple targets? Say empty list. Yeah, we need at least 1. Okay, so now we'll have target indices, and then if not target indices, so if it's empty, then we'll ignore it, and we'll say for index in target indices, res of index equals true. Let's try that. Okay, so now we have true, true, true. And then I just want to return if all of these are, so I'll print res and then return all of res like that. Okay, so it worked for those two. Wow, okay, that actually worked. That's insane. I was completely going on a limb there. Okay. Okay, so if the number of, so let's assume like this is a 1D array and its length will be n. So for every element in triplets, it does constant operations. Yeah, I'm pretty sure this is linear. It does one thing for every operation. Okay, let me try this on LeetCode. So honestly, even though let me make sure it gets accepted. What's it called again? Merge triplets to form target. All right. Let's see here. Okay, so there's a much more efficient solution. Yeah, so the thing is, like, even though, okay, so it does work, and I just want to say, I feel like I don't have a great understanding of the problem, even though it solved it. I feel like I was just I just tried something and it happened to work. I don't fully understand why it works. So there might be an even simpler approach. Yeah, it does look really slow. Could it be because I'm printing? No, I mean, I'm just printing a list of 3 things. Yeah, that's not going to change it. Yeah. So, is there a better way to do it besides just linear? Because I'm basically processing every number once. Here. Is it because I'm doing this function? Is that slowing it down? Maybe I could just get rid of this function and just oh, why does it return? Oh, that's interesting. I'm returning false, and then it says if not false. So this is returning false. If not false, then it will continue. So it works, but yeah, I don't know why this is slow, to be honest. It seems really fast. Like I'm not doing anything really. Here, maybe instead of this array, I can just have a count. No, not really. Because it's possible you could have true for twice. There might just be some math trick or something like that. Or do we just have to check if it's the max? Like, am I doing extra work that you don't actually have to? Could we just check if it's the max in each one? Maybe. $42. I have a little bit more time. So what am I checking right now? I'm checking that each element in the triplet is bigger than... So why am I doing that? So I'm checking that each element in the triplet is bigger than the test case. So let me go back to that other example that failed. So we had two... Wish I could combine this real quick. Yeah. All right. So we have two... What did I have before? Yep. Okay, 5. 5, 4, 6, 9, 7, 7. 3, 5, 5. So in this case, so can we just check, and then our target was 9, 5, 6. So can we just check like, hey, 9's the biggest in its roll. 5 is not the biggest in its roll. Okay, I have another idea. So first of all, if we have 10, 10, 10, right? We rule that out. So we only consider these triplets that have something of interest. But what if we had, for instance, okay, so we had, let's say 9, 9, 0, 0. But we also had 9, 5, let's say 9, 7, 7. So 9, hey, it's the biggest or equal to its roll. So you basically check the max of like, not, is it the biggest in 9, 5, 9, 3? 9, 5, 9, 3, yes. This one you say, hey, is 6 the biggest? So this is where it's tricky because it is here, but it's not here. So you might think, well, can we just discard this one? But what if we have a situation that's like 9, 0, 5, and 9, 5, 0. Or let's say 9, 6, 0. So here the 6. So it has to be bigger than at least one of the 9s. So could it be like, so here with your 6, you iterate until you find a 9. So like you find, I'm bigger than this 5 and this has a 9. So we say 9 is good. I'm bigger than this 5 and this has a 5. So 9 is good. So 6 is good. And do you even have to do anything else? Or do you just know that the problem works? Well, yeah, you do have to do more stuff, because if this is 10 instead of 5, then it would be impossible. So, okay, maybe so for each one. So then this 9 goes, hey, this, I'm bigger than this 5, which has a 6, and I'm bigger than this 3, which has, okay, so maybe so maybe we need to check more conditions. So we can say, so when we find this 6, it has to be true. So the first number has to be smaller than 9. So we'll say, okay, 9 has its 6 because it has its 6 right there. 4 has to be smaller than 5. So then we'll say that 5 has its 6 as well. And then we evaluate this one. And we say, okay, so its target is 9. So then we look at these two. So 0 is smaller than 5. So we'll say 5 also has its 0. And then 5 is smaller than 6. So we'll say that 6 has its 9. And then we'll go here. And this one's target is 5. Or sorry, it's index 1. Yeah, so we'll evaluate these two. So 3 is smaller than 9. So we'll say that 9 has its 5. And then this 5 is smaller than 6. So we'll say that 6 has its 5. And then once you have this, you know that you're good. So is there a more efficient way? Like, can we just have a count? But what if we have like 2 of these? Or if this one comes first? Gets tricky. Yeah, so that's another way you could do it, I guess. But yeah, so I think I'll call the video there. So we did get it accepted. It is a little slow. I'm interested to see the solution for this one. But thank you guys for watching. Today was day 50, and I'll be back tomorrow for day 51.